All right, starting chapter 10, looking at 10.1 and 10.2 today, we're going to look at radical expressions and functions. Radical means you're going to see that square root symbol. That's our radical symbol. You can see that down at the bottom of the slide here. So a number C is a square root of A if you square the C and it's equal to A. So you're going to be very careful with the homework questions. They'll say something like, find the square roots, plural, of 9. The answer is not 3. The answer is 3 and negative 3. 3 squared is 9. In parentheses, negative 3 squared is also 9. So if you see that plural S there, that means you're going to have to find two answers, one positive, one negative. We will also talk about a principal square root. Notice that this is singular. That means we're always going to look at the positive value for the principal square root. Now, the principal square root associates with the square root symbol. So once you see the square root symbol, they want only positive answers coming from that symbol. So the square root of 25 is 5. Square root of 49, 7 on the top. Square root of 64, 8 on the bottom. Now if they put a negative out in front of the square root, you'll still take the square root of 36, which is 6, but you keep the negative on it. That's like saying negative 1 times a positive 6. That will be a negative 6. The square root is 0.0144. You don't need a calculator. When you work with decimals and square roots, you have to have an even number of decimals. All right? So think of this as 144. And the square root of 144 is 12. Since you have 4 decimal places, that will be cut in half to 2 decimal places. So your answer will be 0.12. If this was the square root of 0.144, you couldn't do this by hand. You'll have to go to your calculator. All right, simplify. Now, here's where the author is going to start to fool you. Remember, these are principal square roots, and your answers must be guaranteed positive. So I see the square root of 13 squared. Oh, that's just 13. And you'll probably get 2 or 3 of these in a row, like, oh, the square root of 17 squared, 17. The square root of 23 squared, 23. The square root of negative 4 squared, negative 4. No, it is not negative 4. That's not a positive answer. By definition, the square root symbol is a grouping symbol, which means you have to simplify the inside first. So a negative 4 squared is negative 4 times negative 4 is a positive 16, and the square root of 16 is a positive 4. Okay? Guarantee it to be a positive answer. All right, let's throw another curveball at us. The square root of the binomial x minus 2 squared, okay, it's not the binomial x minus 2. Here? That's right. Are you guaranteed this is a positive value? For example, if x was negative 1, this would be a negative 3. Squared 9, the square root of 9 is 3. And if x is still negative 1, my answer is negative 3. So how do we guarantee this to be positive? You put absolute value bars around it. Now if I have a negative 1 minus 2 is a negative 3, and the absolute value of negative 3 is positive 3. Guaranteed positive. All right, the square root of x squared minus 8x plus 16, you cannot take the square root of the terms individually. It's all of it or none of it. So therefore we need to factor this. All right, so here we go. What two numbers multiply to be 16 and add up to be a negative 8? Oh, x minus 4, which happens to be the square root of x minus 4 squared. We're running into this condition again. So my answer is the absolute value of x minus 4. Wow. All right. Well, how do I know I always need to keep absolute value bars around? So here's the absolute value bar rule. If you start with an even root, now since there's no numbers there, you could consider putting a 2 there, or a 4, a 6, an 8, a 10. And you have some variable quantity, parentheses, x's, numbers, and if it comes out to an x, or that expression to an odd power, this is technically x minus 4 in parentheses to the first power, you have to put absolute value bars around it. All right? Okay, so here we have the square root of square root of x to the 8th power. Gazinter rule, like I said, you can put a 2 on the ledge of the square root symbol. And you ask yourself, 2 goes into 8 4 times. Now notice this started with an even root, but we finished with an even power. So I do not need absolute value bars. If you put absolute value bars around there just to say, oh, I want to make sure, it will mark it wrong, because when you take anything to the 4th power, guaranteed positive. Square root of x to the 6th. All right. 2 on the ledge. 2 goes into 6 3 times. Now this is x to an odd power. This will need absolute value bars. We have the square root of x to the 10th, y to the 12th, z to the 4th. 2 goes into 10 5 times. 2 goes into 12 6 times. 2 goes into 4 twice. So here you can put absolute value bars around the whole thing if you wish, because you have the x to the 5th. But in some of your homework, they're only going to want the absolute value bars around the variable with the odd power. So if that happens, and you type this in and it's wrong, then switch your absolute value bars just around x to the 5th, and the even powers can stay on the outside. All right, now we're going to cube roots. The number c is a cube root of a. If c to the 3rd power is equal to a, then the cube root of a is equal to c. So the cube root of 8, if you take the 8 and break it down to 2 and a 4 and a 2 and a 2, this is really the cube root of 2 cubed. They cancel each other out, and 2 is the answer. 27 is 3 times 3 times 3. The cube root and the power of 3 cancel. 3 goes into 3 once, 3 to the 1st power. Careful with 64. We saw this when we were factoring the difference of perfect squares and perfect cubes. 64 is also a perfect cube. 4 times 4 times 4. The cube root of 4 cubed is 4. The cube root of negative 8 can be done. If I broke this down, it's negative 2 times 4, and negative 4 can be negative 2 times negative 2, so the cube root of a negative 2 to the 3rd power is a negative 2. So you'll notice here there are no roots. They're all singular. So the cube root of a positive number is positive. The cube root of a negative number is always negative. So any odd root can be done for an positive or a negative value. So cube roots, you do not have to worry about absolute values. Remember, that's only an even root rule. All right, the cube root of y cubed, Gazinter rule. 3 goes into 3 once. Cube root of negative x to the 6th power. Now notice here that we do not have parentheses around the negative x. All right, so the negative is like a negative 1, and the cube root of negative 1 is a negative. 3 goes into 6 twice, negative x squared. Not in parentheses, guaranteed that this answer will be negative. Cube root of 9, 3 goes into 9 3 times, z cubed. Cube root of negative 27, x to the negative 15th. Okay, cube root, we saw 27 was 3, but it's negative, so negative 3. 3 goes into 15 5 times, negative 3x to the 5th power. Next, we're going to go to nth roots. Now we can talk about any root. 4th root, 5th root, 6th root, 7th root, 8th root, 9th root, 10th root, doesn't matter. Your root is on the ledge. Also, you'll see in the homework, they may call it an index. It's the same thing. Root and index is the value on the ledge. Radicand is everything on the inside. The 5th root of 32, break the 32 down to 2's. 2 times 16, 16 is 4 and 4, 4 2's, 5 2's all together. The 5th root of 32, or the 5th root of 2 to the 5th, is 2. If it's a negative, it's odd, it's just going to be a negative 2. 4th root of 81, that's 9 times 9, and then we got 3, 3, 3, 3, 4 3's. The 4th root of 3 to the 4th is 3, multiplied by that negative, negative 3. The 4th root of a negative 81 cannot be done. You cannot have a negative inside of an even root. That is not possible. That's your undefined, or DNE, does not exist. 7th root of y to the 7th, 7 goes into 7 once. 6 goes into 6 once, so that's a negative x. No, it's not. It's an even power. We have an even power, even root, even power. 6 negatives is going to become a positive. So this would be x to the 1st power. Now, if you were to accidentally go, oh, it's negative x in parentheses to the 1st power, even root to an odd power, absolute value bars. So this gets absolute value bars no matter what. Because, again, it's a negative x. X could be a negative 1. Okay, the negative times the negative is positive. We don't know if it's going to turn out positive or negative. So we guarantee it. Even root, odd power. All right, start with odd root. 9th root of x minus 1 to the 9th power, x minus 1. We don't have to worry about absolute value bars because we started out odd. The 10th root of x plus 4 to the 10th power. X plus 4 all to the 1st power. We're done, right? Nope. Even root finishes with an odd power. You need your absolute value bars. So, what's going to happen when it comes to the test? Glory be, how do I know if I have to have absolute value bars or not? Well, let me show you. We'll write this down somewhere in your notes. A little trick in what to do when it comes to the test. So let's say we have problems 1, 2, 3, 4, 5, 6, 7, 8. And you have a square root, a 5th root, a 4th root, a 6th root, a 7th root, an 8th root, and another square root, and let's say 8 is a cube root. So if I'm taking my test, what I would do is the following. If I don't see an index or a root number, I'm going to put a 2 there. And then I'm going to take every problem number, and if I see an even root, I'm going to put absolute value bars around it. Okay, so here's a 5, I don't need it. Here's a 4, absolute value bars, absolute value bars. Odd root, even root, absolute value bars. Oh, need to put a 2 there, absolute value bars, odd. So what that reminds me is that I need to check my answer, and if it's raised to an odd power, then we're putting in the absolute value bars. So 1, 3, 4, 6, and 7, I'll have to check for absolute value bars. If number 3 happened to have my answer and it's raised to the 2nd power, I don't need it because it's not an odd power, it's an even. All right, so that would be my suggestion on how to prep yourself for the test for those problems. All right, what is the domain of these possible crazy functions? Well, the biggest issue is going to be the even roots. Even roots must have non-negative values, 0 or positive, inside the radicand. All right, so what we're going to do is, this is a square root. It's an even root. You take the radicand x minus 3 and you set it greater than or equal to 0. Solve it for x, add over the 3, x equals 3. This is the domain for that function. B, g of x equals the fourth root. Okay, it's an even root, 8 minus 2x. Set it greater than or equal to 0. Now, I don't like negative variables, so I would add the 2x over to the other side because I like my variable term to be positive right away. Divide both sides by 2. 4 is greater than or equal to x. Or if you want the x first, you switch everything around. X is less than or equal to 4. See, it's pointing to the x. It still has to point to the x on the left side. And that's going to be negative infinity, comma, 4 bracket. C, h of x is equal to the cube root. This is an odd root. Then this is automatically all real numbers. There's no restrictions. Oh, D, f of x, it's a square root. X squared plus 9. We're going to set that greater than or equal to 0. Well, wait a minute. I think we saw this once before. There's no possible way to get a negative number in here. Squaring a number is always going to be 0 or positive. Adding a 9 to it will always be bigger than 0. So that's going to be all real numbers. All right, section 10.2. We're going to look at fractions as exponents. So a quick review of your exponent rules. Remember, you have the 0 exponent rule. Be careful of the trick questions. 4x to the 0 is 4 times x to the 0. 4 times 1 is 4. But as soon as you put parentheses around the whole 4x, then it's a 1. Product rule, multiply like bases, add exponents. Remember, don't multiply your bases, just add the exponents. Quotient rule, divide like bases, subtract your powers. Remember, don't cancel your 3's. It's 3 squared. Power rule, 1 base x raised to a power outside the parentheses, multiply them together. Remember your negative exponent rule, x to the negative n. So if I start on the top, it goes to the bottom with a positive exponent. If it starts on the bottom, we move it to the top with a positive exponent. And if it's a fraction raised to a negative power, then you flip the fraction and you can change the power to positive. Your rational exponent or fractional exponent rule works this way. If I have x to the m over n power, then notice that the denominator of my fractional power is really the root. And the power in the numerator is the power inside on the x. Now you could also write it this way. The nth root of x all to the m power. These are interchangeable. Okay? Now, one thing I want to talk to you about when you are going to be taking your test and you're going to be writing these powers. Please do not do this. Oh, it's x to the m over n power. I don't know about you. That does not look like a power to me. That looks like something like 2 to the 3/5. That's a mixed fraction. So when you write your power, this is what we're going to do. X, put the denominator first, then build your numerator. Now, that looks like a fractional power. So if I want a 2 to the 3/5, your 2, power of 5, then put in your numerator 3 fraction bar. That is a fractional exponent. I'm going to be picky on that, so you've been forewarned. Now, some people ask me, why can you have the power on the inside or the power on the inside? When is it useful between the two? Here's when you're worried about that. Let's say we had 8 to the 5/3 power. Okay, that could be the cube root of 8 to the 5th or the cube root of 8 all to the power of 5. So I'm going to ask you, what's easier to do first? 8 to the 5th power by hand or the cube root of 8? Well, wait a minute, I know the cube root of 8 is 2. And then to the 5th power, that's 32. I'm done. So when I want to work with the power on the outside is probably when I'm trying to simplify base numbers, my base as a number. Now, if this was x to the 5/3 power, then I'm going with this right there. Okay, so it's a variable, put the power on the inside. If it's a number, put the power on the outside. Easier to simplify. All right, so one of the skills you'll have to be able to do is convert from radicals to fractional exponents and fractional exponents to radicals. So here we have the cube root of x squared. So this becomes x to the 2/3 power. Here we have now more numbers on the inside. The 4th root of all of this. So technically what we'll do, there's 2 ways this can be taught, is you treat this like a power on the outside of 1. And so we write 2xy cubed to the 1/4 power. But then remember there's a 1 on the 2, a 1 on the x, and you multiply those to the inside powers. And you get 2 to the 1/4, x to the 1/4, y to the 3/4. So what we're going to do is we're going to put our 1s inside right away and go 2 to the 1/4 times x to the 1/4 times y to the 3/4 to get from here to here right away. Now be careful with this 3 on the outside. It's not a root number. The root's 5. But the 3 should not have any fractional powers. So this should be 3 times a to the 2/5 times b to the 4/5. And we're done. All right, fractional exponents to radicals. Okay, 6 root of 7 to the 1st power. The 1/3's on everything here, so it's the cube root. We put 5x on the inside to the 1st power. You really don't need a power there. But if that was a 2/3, then I want to keep this as a 2. And then I could think about simplifying it to 25x squared. 3x, the 3/4 is only on the y, so 3x stays outside of the 4th root of y cubed. So be careful here. All right, simplifying using fractional exponents. So we're just going to use our normal exponent rules just with fractions. 3 to the 1/5 times 3 to the 3/5 of multiplying like bases. Add the powers. 1/5 plus 3/5 is 4/5. Done. X to the 5/6 divided by x to the 1/2. Subtract your powers. Okay, I need common denominators. 1/2 will be 3/6. 5/6 minus 3/6 is 2/6. Oh, that reduces to 1/3. So be aware of your fractional rules. Y to the 3/4 to the 2/3 power to a power. Multiply your exponents. Well, 3 goes in, can cancel. Excuse me, 2 can go into 4 twice. Y to the 1/2. Here we have x to the negative 4/5, y to the 2/3 to the 1/2. You can do it in any order. If you want to take this 1/2 and multiply it to the inside right away, so be it. If you want to take this x to the negative 4/5 and put it in the denominator and then distribute the half, so be it. We can take the negative and put it in the denominator right away. I don't care what order you do it as long as it gets done. Simplify individually. 2's cancel, y to the 1/3. 2 goes into 4 twice, x to the 2/5, and we're done. Simplifying the radical expression by using rational exponents. So as we work this out, you're going to see there's easy ways to do this instead of always using fractional exponents. So you'll see examples and videos in the homework. They're going to say, oh, this is going to be 2x to the 3/6, reduce the power to 1/2, and then change it back to the square root of 2x all to the first power. I'm sorry, I can see this right now. All roots and powers you just reduce by 3. 2 and a 1. Oh, there's the answer. The fifth root of y to the 20th power. Okay, 20 over 5. 5 goes into 24 times. There's my answer. Or Gazinta rule, 5 root goes into power 4 times. All right, here we have the cube root of a squared b all to the 12th power. Let's simplify the 3 and the 12. This would be a squared b all to the power of 4. Distribute the 4 to the powers. A to the 8th, b to the 4th. All right, oh my gosh. Square root of 4th root of x. Time to panic. No, you wait till you find the shortcut for this. This is really 2. Put the 2 on the ledge. Change the inside to x to the 1/4 power. Change the outside to 1/2 power. So x to the 1/4 in parentheses to the 1/2. It's a power to a power multiplying together. It's x to the 1/8 or the 8th root of x. Ding, 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 ding. How can I go from here to here without doing any of this work? You're right. Remember, 2 and 4, they're roots. You just multiply the roots together and call it done. So let's try it over here. The 4th root of the cube root of x to the first power. I'm calling it the 12th root of x. Let's see the fractions go to work. Yep, there it is. You don't have to do this. There's shortcuts. And that wraps up 10.1 and 10.2.